Alright, so I'm back again. I didn't think about the we're doing another question, but I feel like it's slow, I guess. It took uh, a weekend to like half finish, so like think about it, like 2 weeks, 3 weeks, 4 weeks, 5 weeks, six. Like it's gonna take like 3 to 4 months. I mean, it's not a bad thing to do, but like I'm trying to, you know, push myself, push myself in. So let's try another one. So and this time we solved the 2.0 one. So let's do the evaluate. Um, yeah. So evaluate reverse polish notation. What the hell is like reverse polish notation? Since you're given a array string of tokens that represent thematic expression is reverse pulse notation. Um, okay, I mean, I can go read it, but it's Wikipedia, but I'm not gonna read it. Let's return the insert represent the evaluation of the expression. The operand may be integer or result of the other operation. Operation includes. Okay, so I guess which one take comes first? So it's okay to know. Um, I mean, intuitive thinking is just we once we like two pointer once we had it like we know the like what kind of things to do then once we have something to calculate like this and we do this and once we done it we have the result and by using the result and we gonna go for the next one and we once I have it and we looking for the another one. So once we done it, so let me think. So we need some kind of like saver, save valuable, and like we need to save something, like looking for something. Um, so we basically like calculating this, and we take this becomes L again, and this became R, and we doing again. And after we done that, it became L again, and this became R and A. So I think this is the approach. The problem is, what if it comes with the like invalid one, 1, 2, 3, I don't know, plus? Um, so it say valid. So I guess it's we don't have to care about those kind of edge cases, I think, for the sake. Um, at first we let's look check create the lookup table. Basically, like plus. Uh, maybe like we should do something like I don't know. We create a like um, calculate, and we should take some like left and right value, and arithmetic. So if a equal to plus, we are going to return L plus R. Else if a equal to minus, we are returning L minus R. L minus R, yeah, I mean, it doesn't matter. No, it does matter, but so a not what kind of things like multiplication? We return by the multiplication, and then return division. So but we have to be careful about like divided by 0. So how can you do that? Like, this is question to do. So this is valid question. So let's say like we have a left and right, and both initialize to no, actually, let me check the token length, and could be like, you know, so let's get rid of that one things like I don't want to like just initialize it like that. So let's say length tokens is just 1. Just return the first one, because we don't need to calculate anything, right? So then we know that like this is like we are certain that like so now we have to think about the hard, and I guess something. Let's see. So let me think. So somehow we have to detect like this thing, or this thing became the so let me think. Let's think about the condition later. Let's implement the inside. So left. So no, actually, like we have to do it in this way, and it's like, what are we gonna do about it? Like if only 2 token comes in. Now, that's another question. Like what? What do we need to do with that? So at least 3 of them. So basically, we'll have a result, and result became calculate left R and A. And A is not just A, we are need 2 tokens and A, and is all the things are same. So we have to actually token. So once we done it by using result, so left become result. I mean the left side. So like we are cooked. So here we have to make it. We have to cast it first. And in this case, So left is not moving, and no, like left is actually moving, but we are just going forward and forward. So now let's while right is length of tokens -1, no, -1, because we shouldn't go that far. Yeah, so if R, no, so at this point it should increasing. Not exactly, like we could increase by 2 and we don't need this, and we just increase by 2. The only downside of this doing it is that result, we just need to use the result. So we just add this once, and we're doing this, and all we have to do is like make sure we are not going out of bounds. So we have to make sure that like tokens, so R actually and A length tokens -1. So this, in this way, we'll make sure and return result. So let's check it once. Out of bound. Nope, like we stuck in the second one. Yeah, like in this case, like how are we doing that? I think it's like it is lack of information. Like, so why this is that? Because we are first wait for truncate, like we need to do this, and so we are doing it, and we truncate, and I guess this became shared 0. Yeah. Actually, I don't understand the problem. Like, how does this thing work? I don't know. I really don't know. Why? Huh? I I really don't know. I don't understand. I think it should. I would like to have more information about it. So how does it this become 6? So I guess divide by 2. So I guess those thing divide 13 divided by 5 and plus. Yeah, I think so. I think so. Um, then like I understand the problem incorrectly. So in this case, like we have to just actually move um like all the way, like to happen. So once we done it, like um, we are moving backward, and we're doing this. I think. Don't we need to like check what kind of thing are we missed? Um, okay. I guess yes, you're right about it. Because we are only thinking about this like 2-pointer or 3-pointer. It's gonna take a while, and what we need to do is just push. Like if we see any kind of numbers, we just push into stacks, and yeah. So first one become second one. Yeah, I think that is more um, viable solution. So let's actually create lookup set. No, like set um, minus multiplication. Yeah, so let's remove that, and if we see stack, so if we, well, no, like 4 for I, for X in stack. No tokens. And what? And what we need to do is like if X is not in nothing, not in sin, nothing. Let me check. Python except sin. I thought I had we had something like that. Python sets and maybe I'm just confusing with the other one. Okay, I think I'm confusing with the other one, so pen, I think. Before we do that, like let's at least and check what's in there. Alright, so let's what about that? Just set. Alright, so set not in local table. It means this means an integer. So we are going. So we are going to stack append, and we are casting, and else if it's not, else we are going to pop so right and left. We are going to pop again, and we are going to send it to here. And I mean, tag casting is done by there, so let's not cast that. So left, right, and the current one. So this we are going to put it in the stack. Right? So in the end, results should be just pop. Else. So 12. Okay. 12. Maybe we looping is wrong. So 12, because I did 12. Something. And what did I do wrong? So integer something. I think I did right. I don't know. Probably. Well, it is going to be painful. So this is why. Right. Yeah. Let's print stack here, just in case. I'd like to see what's in there. The calculation went right, so let me do calculation. Decimal, so 12 plus, yeah, we done that, 12 multiplied by 11. So negative 132. And divided by 6, it still is negative. And multiplied by 10, negative 222. And plus, I mean, it should be minus, because it's negative. And minus 5. Huh? Let me check the answer. I fully don't understand the thing. So brute force. Recursion stack. I mean, is that could be, but isn't that doing the same thing? Maybe this is the problem. No. Yes. No. Yes. No. Like this is not the problem because they get like for lab test. That one. The other one is just. I don't know. Maybe let's try. I mean left, right. last one, isn't it? I mean, stack has only one. Yeah. What? Oh. Okay, I think it's still popping is correct one. Yeah, this was the problem. I thought, um, I don't know. I, this is not that I wanted it. Because, maybe we don't need this. Yeah, I guess so. Um, but I obviously need some work and why I need to look up like why and this is different. Alright, thank you for watching.